Today we are going to discuss about ANOVA. In this session we will discuss what is ANOVA and what are the different types of ANOVA, which type of ANOVA is used when, and what is the formula of ANOVA we are going to discuss in this session. Now, what is ANOVA? ANOVA is analysis of variance. ANOVA is analysis of variance test, which is used in statistics. ANOVA is actually written by Ronald Fisher. ANOVA is actually written by Ronald Fisher. ANOVA is also called the Fisher analysis of variance, and it is the extension of t-test and z-test. The term ANOVA became well known in 1925. Analysis of variance or ANOVA is a statistical method that separates observed variance data into different components to use for additional tests. ANOVA is a statistical method which separates the observed variance data into different components which can be used for additional tests. In data analytics, ANOVA is analysis of variance is an analysis tool used in statistics that splits an observed aggregate variability found inside the data sets into two parts. The first part is systematic factors and the second one is random factors. The systematic factors have a statistical influence on the given data set. The systematic factors will have a statistical influence on the given data sets, while the random factors do not have any influence on the given data sets. So, analysts use ANOVA test to determine the influence that independent variables have on the dependent variables. ANOVA is also used for determining the influence that independent variables have on the dependent variables in regression study. Now, when to use ANOVA? ANOVA is used when we compare or when we analyze more than three groups. When we analyze more than three data group sets. If we want to compare only two sets, then we can use t-test. If you want to compare more than three groups test, then we go for ANOVA test. So there are two main types of ANOVA. First one is one-way or unidirectional ANOVA, and the second one is two-way ANOVA. The names one-way and two-way refers to the number of independent variables in a analysis of variance test. One-way and two-way refers to the number of independent variables. So in one-way ANOVA, the number of independent variables is only one group independent variables, and in two-way ANOVA there are two independent variables. One-way ANOVA. Now we will discuss about one-way ANOVA. One-way ANOVA determines whether all the samples are the same or not. Whether all the samples are same or not. And the one-way ANOVA is used to determine whether there are any statistical significant differences between the means of three or more independent groups. Between the means of three or more independent groups. As we said, ANOVA is used for more than two groups. Hence, one-way ANOVA is used to determine differences between means of three or more independent groups. A one-way ANOVA is used for three or more groups of data to gain information about the relationship between independent variables and dependent variables, the relationship between dependent and independent variables. And the next one is two-way ANOVA. A two-way ANOVA is an extension of the one-way ANOVA. The two-way ANOVA is an extension of the one-way ANOVA. With a two-way ANOVA, there are two independent variables affecting a dependent variable. In a two-way ANOVA, there are two independent variables affecting a dependent variable. For example, a two-way ANOVA allows a company to compare workers' productivity based on two independent variables. A two-way ANOVA allows a company to compare worker productivity based on the two independent variables such as salary and the skill set. It is utilized to observe the interaction between the two factors and tests the effect of two factors at the same time. So, if for example a company wants to uh, find the productivity of an employee, so the productivity can be identified by his skill set by comparing with their salary. Hence, so the two groups, salary and skill set, are independent variables. They can be compared. The impact is observed by using two-way ANOVA. So, it is utilized to observe the interaction between the two factors and test the effect of two factors at a same time. So, in such kinds of situations, we can use two-way ANOVA. And now, the formula of ANOVA. The formula of ANOVA is F is equal to MSE divided by MST. So, what is MSE and what is MSE? Here, F is the ANOVA coefficient. Here, F is the ANOVA coefficient. And MST is the mean sum of squares due to treatment. MST is the mean sum of squares due to treatment. And MSE is the mean sum of squares due to error. Mean sum of squares due to error. After finding F, after finding ANOVA factor, ANOVA coefficient F, if no true variance exists between the groups, if no variance exists between the groups, the ANOVA's F ratio should be equal or close to 1. If there is no variance between the comparing groups, between the three or more groups, then the F ratio, that is ANOVA coefficient, should be equal or close to 1. So if F is equal to 1 or very near to close, then we can conclude that there is no variance exists. There is no true variance exist between the groups. So that is about what is ANOVA and different types of ANOVA and the formula for ANOVA. And finally, ANOVA is a statistical method and a statistical tool which can be used for analyzing data of three or more different groups. Three or more different groups. And ANOVA is of two different types. One is one-way ANOVA and two-way ANOVA. One-way ANOVA will have one independent group, and in two-way ANOVA, two independent groups. So as the name suggests, the name represents one-way or two-way represents the number of independent variables affecting the dependent variables. And finally, the formula for ANOVA is F is equal to MSE divided by MST. F is ANOVA coefficient. So that is about ANOVA and different types of ANOVA. Thank you.